Hi everyone, in this lecture I'm going to talk about chapter 9 inheritance in Java. So the goal of this chapter is to first learn about inheritance and understand how to inherit, override superclass methods, and then to be able to invoke superclass constructors. We also learn about protected and package access control, and we'll understand the common superclass object and to override it to a string and equals method for different subclasses of object. Basically, inheritance means to extend classes by adding methods and fields to it. For example, if you have a class already defined named bank account, and then you want to extend that bank account by adding some new methods and fields, you can write it this way. You can write class, for example, a specific type of bank account like savings account extends bank account, and then inside braces you can put the new methods and instant fields that are specific to savings account, because savings account automatically inherits all methods and instant fields of the bank account. It's superclass, but you can also add new methods and fields that are specific to this kind of account, which is savings account. Besides, you can use the methods that you can previously use for a bank account, like deposit. For example, if college fund is a savings account, you can first create an object of a savings account and then set it equal to college funds. And then after that, you can simply call the deposit method that exists for bank account. And since college fund, which is a savings account, uh, inherits all methods of bank account, it is okay to use deposit with the savings account object. In the previous example, the bank account, which is the superclass, is called the extended class, while the subclass, which was the savings account, is called the extending class. So remember this terminology. And also keep inheriting from a class is different from implementing its interface, because subclass inherits behavior and state. Also, one advantage of inheritance is code reuse. In this lecture, we use a specific type of datagram that shows the inheritance relationship between classes. As you see here, we have three classes here: savings account, which is a subclass of bank account. And since savings account is a subclass of banking account, we have an arrow from savings account from the subclass to the superclass, from the extending class class. And then you need to know that every class in Java extends the object class either directly or indirectly. For example, here, bank account extends object class by default. So let's take a closer look to the example that we just saw. In class savings account, which extends bank account, we need to specify the added instance fields and methods that are not in the bank account and are not inherited from bank account. For example, the savings account needs its own constructor. So here we write constructor for savings account, which gets rate as an input. Rate is a double, and it basically specifies the interest rate of the savings account. You know that not all accounts have interest rate. That's why interest rate which is specific to savings account has to be defined here inside savings account. And then we have another method called add interest. This method simply calculates interest first by multiplying interest to get balance and dividing by 100, and finally it deposits that amount, that interest amount. Obviously deposit is a method that is defined into the in the superclass, which is the bank account. It is not defined in the savings account, but still we can call this method. And lastly, we have another instance field in savings account class, which is called interest rate. Obviously, interest rate is not inherited from the superclass because not all bank accounts have interest rate. And then you need to note that in this example, when we were going to obtain the balance of an account in the savings account, we call getBalance. And whenever we wanted to uh, change the balance, we use deposit. So the add interest method in savings account has no access to the private fields of its superclass like balance. Instead, it can call the get balance method so that it can read those variables, like in this example, balance, and write on them by calling another method. In this example, it was the deposit method. So this feature that you cannot have access to the private fields of your superclass is called encapsulation. Also, note that the add interest method called get balance without specifying any implicit parameter. So it just calls it in a way that it is defined inside the class. In fact, it's not defined inside the class, it is defined in its superclass. But still, you can call it without specifying an implicit parameter. So if we look at the layout of a subclass object, you can see that it has two parts. It stores all the instance fields of its superclass. In this case, for example, balance, which belongs to the superclass bank account, and also it has another portion which stores its own instant fields, the instant fields of the savings account that is not inherited uh, from the superclass. So we have balance, which belongs to the superclass. We have interest rate, which belongs to the savings account itself. We can have a hierarchy of inherited classes. For example, consider J component in Java. This class has methods get width and get height, but it has a lot of subclasses: JPanel, JText component, JLabel, and abstract button. And even the subclasses like abstract button have their own subclasses. So, for example, the abstract button class, which has methods to get and set button text and icon, has two subclasses: J toggle button and J button. These are the two specific kinds of buttons, two specific kinds of abstract buttons. And then another inheritance level exists with J toggle button. J toggle button has two subclasses, J checkbox and J radio button. So as you see, when you construct the diagram for all the inheritances in different layers, we'll create a tree in which the J component is at the root of the tree, and we have different layers of inheritance in this tree. So, in the example of bank accounts, consider that a bank can offer uh, the following two types of accounts. One is a checking account, and the other is savings account. The checking account has no interest, and you can do small number of free transactions per month, but additional transactions are charged a small fee. For savings account, uh, we need to have some mechanism to earn interest that compounds monthly. But in order to implement these functionalities in Java, uh, we know that all banks should support all bank accounts should support the getBalance method and the deposit method and the withdraw method. So we put all of these functionalities in the bank account. But the deposit and withdraw method for different bank account types uh, should be implemented differently. Also, checking account needs a method called deduct fees, and savings account needs a method called addinterest. So both the savings account and checking account, they both extend bank accounts, so they are both subclasses of the bank account, but each one of them need to define a different method. As I said, checking needs to define deduct fees, savings need to define uh, add interest. Also, the difference between implementation of deposit and withdraw should be specified in the body of classes, checking account, if needed. For the checking account in the previous example, obviously we need a counter that counts the number of withdrawals and deposits so that we know that how many or which transactions are free and which ones are not, and we deduct fees for the ones that are not free. So the counter that counts the number of withdrawals and deposit in checking account is a new instant field that does not exist in the bank account, and it's not inherited by the superclass of checking account. When a class inherits a method from its superclass, it can supply a different implementation of the method that exists in the superclass. We say that the subclass overrides the method of the superclass. Uh, when a class overrides a method, have the same signature, which means that you have to keep the name uh, the same as the superclass, and you have to keep the same parameter types as are defined in the superclass method. If method is applied to an object of the subclass type, the overriding method is executed. But if the method is applied to an object of the superclass type, obviously we are not going to execute the overriding. We will use the original implementation of the method. The second type of inheriting a method is to just keep the implementation of the superclass additives and reuse it in the subclass. So basically, if you want to inherit a method, you don't need to supply a new implementation of the method that exists in the superclass. Basically, the superclass method can be applied to the subclass objects if you don't override that method. And then the third type of inheriting methods in Java is to add a method. You supply a new method that does not exist in the superclass. So new methods can be applied only to the subclass objects because the superclass uh, doesn't have those methods. How about inheriting instance fields? Can we override fields? The answer is no, it's not possible. However, you can inherit a field. All fields from the superclass are automatically inherited. Moreover, you can add a field. You can supply a new field that doesn't exist in the superclass. But the question that may raise is that what if you define a new field with the same exact name as a superclass field? In this case, each object would have two instance fields of the same name, one for their superclass, one for themselves. And then the fields can hold different value, obviously, because uh, we have two different memory cells. uh, each one stores the value of stores the value of the field belonging to the superclass, and one stores the value the subclass. So it is legal, but it's extremely undesirable because it creates confusion. In the example of bank accounts, as you remember, we said we need to provide a different implementation for deposit and withdraw in checking account because we are going to keep track of the number of transactions so that we can charge the customer if he or she wants to have more than a limited number of transactions per month. So basically, we need to override the deposit and withdraw method of the superclass to increment the transaction count. So in the class checking account, which extends bank account, we need to provide a new implementation of the deposit and withdraw method, which means that we need to override these two methods. Also, we need to have a new method for deduct fees, and also new instance fields. Uh, we know that each checking account object should have two instance fields. One is the balance that is inherited from bank account. Another is transaction count, which, as I said, keeps track of the number of transactions per month. So that is a new field to checking account. Other bank accounts don't need that. So in the example of bank accounts, you can apply these four methods to checking account objects. You can apply the getBalance method. Why? Because it's inherited from bank account. You can apply deposit method, which which is defined in the bank account, but it is re-implemented in the checking account. So a deposit overrides bank account method. Therefore, you can use it. You can apply withdraw method to a checking account object because again, it overrides the bank account method. And also you can apply the deduct fees to a checking account object because it is a new method defined in checking account. So call this method too. So let's take a closer look at the deposit method of checking account. In that method, we need to first increment the transaction count by 1 and then add the amount that you're going to deposit to the balance. Okay. In order to add amount to balance, we can't just add amount to the instance field balance, because the balance instance field is defined in the superclass, and the balance is a private field of the superclass. Because of the encapsulation, the subclass has no access to private fields of its superclass. So the subclass must use the public interface that its superclass has provided. In order to solve this issue, we can simply invoke a superclass method. In this case, we can invoke the bank account's deposit method, but you cannot just call deposit method in deposit method of checking account. So you cannot call the same method name inside the definition, inside the body method. That would be considered as a recursion. We'll talk about recursions later. So instead, you need to explicitly say that you are calling the or you're invoking the method of the superclass. That's why we use the word super. It's a keyword. We write super dot deposit and the amount. So this way, the Java compiler would know which method to invoke. So it doesn't invoke the deposit method of the subclass, which overrides the superclass's deposit method. And instead, it calls the original implementation of deposit method that is defined in the superclass. So this is how you invoke a superclass method, by using the keyword super before deposit. We have another keyword, this. If you write this.deposit, it will call the deposit method of the checking account. So this is not what we want. This would create a infinite recursion. But instead, we want to call the deposit method of the superclass. That's why we write super dot deposit, and inside the deposit method, we write the explicit parameters, which is in this case amount. So this is how we define deposit method in uh, checking account, or in other words, this is how we override the deposit method of bank account in checking account class. We first increment the transaction count in the first line, and in the second line we call the deposit method of the superclass, because the implementation that we need for the checking account class is exactly the same as the super class. However, it needs to keep track of the transaction count. Therefore, we need only two lines. In the first line, we increment transaction count. In the second line, we call the superclass's deposit method. In the same way that we override the deposit method, you can override other methods like withdraw. In this example, in this slide, as you see, the withdraw method is overridden in the similar way. Um, we first increment the transaction count, and then we call the withdraw of the superclass with the same explicit parameter as the one that is given uh, at the explicit parameter of withdraw method in checking accounts class. Also, here is a method that we define in the checking account, and it doesn't exist in the superclass. So deduct fees has to be implemented for the first time because it's a new method inside the checking account class. So here is the body of this method. We say if transaction count is greater than free transactions, it means that we need to deduct some fees from the customer because the customer is using more than the limit of free transactions. Therefore, you have to first calculate how much fee you are going to deduct from the customer by this mathematical formula, whatever that is. And then after that, you can simply call the withdraw method of the superclass, and inside the explicit parameters you simply pass the fees, which is the result of your previous calculations. At the end of deduct fees method implementation, we need to reset the transaction count to 0. Also, you see that we have some new instance fields for the class uh, checking account. We have a final, which means a constant integer that is defined private, called free transactions, which shows how many transactions are free in a month. In this example, that final variable equal to 3. And then we have another constant which specifies the transaction fee. In this case, it is $2. A common mistake that beginners make when dealing with inheritance in Java is that uh, they solve the problem of accessing the uh, superclasses private fields by creating one inside the subclass. For example, they want to uh, in, have access to balance field of the account uh, in their checking account implementation. But since balance in bank account is private, they create their own balance. And then they increment the balance by the amount in the deposit method. This is obviously wrong because this balance that you define inside the checking account class is stored in a different place than the balance of your superclass, which is the bank account. So you would have two different methods, two different instance fields with the same name that are stored in different uh, places in memory. And uh, when you are changing the balance here in the checking account, that change will not be reflected in the superclass. So everything would be wrong after this point, because if you want to make a deposit, or if you want to make, it doesn't change the balance of the superclass. It changes the balance of a new instance field that you created in the subclass, and you called it the same as uh, the superclass's balance. This mistake is called shadowing instance fields. So we have two different balances. This is the balance. The first one is the balance of the uh, superclass bank account, and this one is the balance that you define inside the body of checking account class. So when you are depositing, when you are calling the deposit method, it doesn't update the correct balance. It updates the balance that you have inside your checking account. However, you expect that it changes the bank account, which is not the case. That's why shadowing instance fields cause errors. As we know, every class needs a constructor in Java. So if you assume that we have a checking account that extends a bank account, obviously checking account needs to have a constructor. So inside the constructor of a checking account, we have to first construct the superclass. So this is how we invoke the constructor of the superclass. We write the word super, and in parentheses, we write the explicit parameter that we need to pass to the constructor of the superclass. After we are done with constructing, we can simply initialize the instance fields that are new in the subclass, and they are not inside the superclass. Therefore, by calling the superclasses constructor, they are not initialized. So in this case, transaction count was the field that we added to checking account, and it wasn't in all the bank accounts. Therefore, after calling super initial balance, we need to call transaction count is equal to zero. We need to write transaction count is equal to zero. This is how we initialize the transaction count inside the constructor of the checking account. A very important point here is that the call of superclass constructor must be the first statement in the subclass constructor. So in the first line, before anything else, you need to call the the superclasses constructor by using the word super. Now, here is the question. What happens if the subclass constructor doesn't call the superclass constructor in the first line of its constructor method? In this case, the default superclass constructor is invoked automatically by the compiler. So what is default constructor? The constructor with no parameters, with no explicit parameters, is called the default constructor. If all the constructors of the superclass parameters, and we don't define any constructor with no parameters in the superclass, then the compiler reports an error because the compiler fails to construct the superclass before constructing the subclass.